Hello guys, it's Miss Hanley here. I hope you're having a great day and you're really loving the systems of equations and inequalities. So now that you've seen how to graph an inequality, we're going to start to put more than one together. And by the end of this unit, you guys are going to be looking at what happens when 3 or 4 or 5 inequalities all intersect on the same graph, and that's in relationship to some sort of problem we're trying to solve. And in the beginning, you looked at break-even points, and this is one of the things we can talk about here. But inequalities give us so much more than that, because when you have, everything that's less than or greater than some value, you don't just get one answer to your solution. And in real life, there's often not one answer that we're looking for. We're usually looking for all the possibilities. And so that's what inequalities allow us to do. So let's go on and see how to graph these. Alright, so you should have these notes in your packet. I'll print it out for you. And we have two different equations here, or inequalities, sorry. The first, x plus 2y is less than 8. And we also have 2x plus y is greater than 10. And if you remember from the previous video and from that work that you did, when you need to graph an inequality, you first need to solve for slope-intercept form. So my first step here is going to be to take this first inequality and solve it for y. And by doing that, I'm going to take away x from both sides. So I end up with 2y is less than negative x plus 8. And then lastly, we have to divide each of our components by 2. And don't forget the golden rule of inequalities. If you multiply or divide by a negative, you have to switch your signs, your inequality signs. And so then we simplified here. We have y is less than, I didn't divide by a negative, so I don't have to change anything. And looking at this value right here, negative x over 2, that's really the same thing as negative 1/2 x. And then 8 divided by 2 would give me plus 4. So there is one of the inequalities that I can graph. Now we also want to go ahead and do that with the second inequality they gave me. So on the left-hand side, it's 2x plus y, standard form. So we need to take away the 2x from both sides. And y is greater than negative 2x plus 10. I did not multiply or divide by a negative, and there's no value in front of y, so I don't have to switch my sign or worry about anything like that. So there is my second inequality. And lastly, they're also giving us the values x is greater than 0 and y is greater than 0. So I wanted us to think about what this is actually saying right now. So I'm going to start with those two. X is greater than 0. Well, that tells me that I am only using the values that are going to be greater than 0 on my x-axis. So I'm not including anything back in the negatives, and you can see your graph doesn't even have the negative portion because we're not going to need it. So we are only going to be using 1, 2, 3, 4, 5, and anything greater than 0 on our x's. Same goes for our y values. If y is greater than 0, I don't have any negative y values. I am only using the ones greater than 0. So I always start by graphing those two lines first because they're the simplest. And x is greater than 0, well, that is just, if it's an x equals line, remember that's your y-axis, it's vertical. So, and because it's just a greater than, I'm going to have a dotted or a dashed line. And then from there, I'm going to shade everything that is greater than 0, which would be everything to the right. For y is greater than 0, that's going to be your x-axis. Again, dotted because we're not including the 0. And everything greater than that would be shaded above. Okay. So now we have to graph the actual two equations that we really have there. And so I'm going to pick a different color, green. Excuse me. And I'm going to graph this guy in green. So y is less than negative 1/2 x plus 4. That tells me I need to start at my y-axis on 4, and then I'm going down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. I'm just going to take this all the way down until I actually hit my x-axis, because that'll tell me where that entire line falls. It's just a less than, so this is just a dashed line, not a solid line. And I want everything less than that, so we're looking inside this bottom chunk right here. Excuse me. Alright, and then let's try this last line we'll do in purple. So I'll start at positive 10, and here negative 2 is negative 2 over 1, so I'm going down 2 to the right 1, 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 down 2 to the right 1. Again, we have our dashed line, and this time we have a greater than symbol, so I'm shading everything that is greater than that purple line. Okay, and so we have a lot of different colors going on, and when you guys actually start graphing these, I would suggest to use different colors because it's much easier to see where your solutions are. So the solution to this system is where all of these different shadings are overlapping, and it has to be all of them. So it has to be where you're greater than the y is greater than negative 2x plus 10. We're greater than that purple line. We have to be less than the green line, negative 1/2 x plus 4. We have to be greater than 0 on our x and greater than 0 on our y. And so that is happening in this little triangle right down here. That's where all of that information is overlapping, right? A lot of times people get, a little hasty and they'd say, oh, well, it's all going to overlap in this section right here. But really pay attention to your signs, because that purple line had a greater than symbol. You're only looking at this little triangle right here. Another thing to be careful of is that you're not just finding one point anymore. It's tempting to say, okay, well, this is the solution to our system, which would be true if you only had these two and they were equations. But because they're inequalities, we're dealing with a whole bunch of other information. All right? So keep that in mind as you go on to the next part, that finding your solution and making sure that we know which part is our solution is really important. So shade that in extra dark, and we'll move on to the next part of this. Okay, so once you've determined where all of your shading is going to overlap, the next step is going to be identifying solution points. So let's take a look here and see what we actually have for solution points. So we have this little triangle that we talked about before, and the vertices are sort of the points that hold this shape together. So they would be, if you remember from geometry, the vertices are sort of the end points, or the points where they come together. So this point right here, which happens to be 4, 2, that's going to be one of my vertices. That's one of the edges of this triangle. And then I come down here and I get the point 5, 0. So that's going to be a second vertice. And then I come down here and get the point 8, 0. And that will be my third vertice. If you created a triangle, you should have 3 vertices. If you created a quadrilateral, you should have 4. Again, you might look and say, ooh, maybe this one, 6, 1 is going to be a vertice, but that's not actually an end point of my shape. It's just a point that falls on that segment. So you have 4, 2, 5, 0, and 8, 0. And those into our chart on the next page. So 4, 2, 8, 0, 5, 0. And up here, we have this profit function, 40x plus 30y. Right now, this doesn't mean a whole lot to us. But generally, when we do these types of problems, you came up with these inequalities because of the context of some problem, some real-world problem. And a lot of times it has to do with money or a business. So this profit function, where you can put in both x and y, that's going to tell us which of these combinations we should use in order to get the maximum or minimum profit from what we're doing. So it's very simple. Once you find your vertices, all you have to do is substitute them into this equation here. So the first one would be P of 4, 2. Profit is what P stands for. And so we're just going to substitute 40 instead of X, we're going to put in 4 plus 30, and then instead of Y, we're going to put in 2. And so this would give me 160 plus 60, or 220. All right, and we're going to do that for the next two. Just setting them up here. So you keep the 40 and the 30 every time, and you're just replacing whatever your vertice was. Well, this one is going to be 40 times 8, which is 320, and 30 times 0, so 320 here. And in this situation, 40 times 5 plus 30 times 0, which would give me 200. Okay? And so from this table, and every time you guys have a situation like this, I really want you to make the table. It makes life so much easier. You just look at the right-hand side and look for, if it's the maximum, the largest value. So 320, that is the maximum, okay? And the point that created that maximum would be 8, 0. So that's the combination of things that is going to give me the maximum profit here. And so maybe if I'm selling something, X is one of the items we're selling and Y is the other item we're selling. Well, this tells me that selling 8 of the first item and 0 of the second item is going to give me my maximum profit. In that same respect, you can look at this and look at, for the smallest number, 200, which would be your minimum value. So the combination of 5 of the first item and 0 of the second item would produce your minimum value. Alright, so now go ahead and try assignment 11.